In Chapter 10, we will review what we have learned in Chapter 9 for design of classes. First, let's look at the topics in object-oriented programming: scope, visibility modifier, static modifiers, and final modifier. Static variable and static methods are used to declare class data and methods. We can declare a class constant using final static variables. We can declare a class variable using static variable. We can declare an utility method using static method. Or we can define instant variable and instant method using the following definition. Encapsulated data field we define as private data. Encapsulated method, accessor mutator, we use public method. Unprotected data, we use a public data. Client method, we use private method. Private method can only be used in the same instance or class. Encapsulated data class, private data, public accessor mutator methods. The encapsulated data, so you cannot use direct access to the data. Immutable data class, private data, no mutator methods, and no return pointers. This guarantees a certain data class. The objects won't be changed. Here is a memory allocation for the methods, static variables, objects, instance, and code stacks for method, local variable, and the arguments. Right here we list down what will be initiated by Java Virtual Machine for the field, class variable, main method information, and the method information and constant pool that's stored in the method area. Basically, these are the static variable and the static methods. Java heap store the objects or instance. Java stack store the runtime information for code stack for every code frame for the methods with local variable, return address, and the arguments. Right here, let's look at the static variable and static methods. When the class got loaded by Java Virtual Machine, it will do the following thing: static variable initialization, static block execution, static method execution, instant variable initialization, instant block execution, and instant method execution. And these need the instant members initialization and execution. Would have the static method instantiation and execution. So these need the instance constructor code, and these don't. It will be available when the class is loaded. For the instant variable and instant method, we give an example right here. Say right here we have a method. The line 1, we declare a local variable I equals 4. It will be put into a stack. And then we declare another variable y equals 2. It will push into the stack again. After that, we declare a pointer for the class 1 that will create an object in the heap. And then the returned address will be stored in the code stack in the CLS1 pointer or reference data type. After that, when the method finished, the code stack's data will be popped out, while the object in the heap will remain. Object-oriented thinking. Part 1, Chapter 1 to 8 introduce fundamental programming techniques for problem solving using loop, method, and array. The study of these techniques lay a solid foundation for object-oriented programming. Classes provide more flexible and modularity for building reusable software. This chapter reviewed Chapter 9 and improved the solution for a problem introduced in Part 1 using the object-oriented approach. First, let's review the concept of class abstraction and encapsulation. Class abstraction means to separate class implementation from the use of the class. The creator of the class provides the description of a class and let the user know how the class can be used. The user of the class does not need to know how the class is implemented. So basically, you hide the detail for implementation from the user. That's what we call class abstraction. And encapsulation keeps the data safe by using private data public accessor mutator. To design a class, we need to look at the coherence. A class should describe a single entity, and all the class's operations should be logically fit together to support a coherent purpose. So one purpose, one entity. You shouldn't combine student and staff in the same class because student and staff have different entity, different purpose. So student, subject, score sheet, card, deck, hand that we use in chapter 9 is following this guideline. Second, to design a class, need to have a separating responsibility. A single entity with too many responsibilities can be broken down into several classes to separate responsibility. The classes string, string builder, and string buffers all deal with strings, for example, but have different responsibility. The string class deals with immutable strings. The string builder's class is for creating mutable strings, and the string buffer class is similar to string builder, except that string buffer contains synchronized methods for updating string. So these three classes all deal with strings, but with different purpose. Designing a class, classes are designed for reuse. User can incorporate classes in many different combination orders and environments. Therefore, you should design a class that imposes no restriction. So basically, you cannot assume that user knows something. You should only design something follow the guideline that you provide some information for the users. You shouldn't assume they know something more. So no restriction on what or when the user can do with it. Design the properties to ensure that users can set property in any order with any combination of value and design method to function independently of their order of occurrence. Design a class, provide public no-argument constructor, and override the equal and the toString method define an object class whenever possible. Because all of the classes are belonging to the subclasses for objects for the data classes. So usually we need to override these two methods. Following standard Java programming style and the naming convention, always place the data declaration before the constructors. Now we call it data field. And place constructor before methods, because constructor has no return value, and methods does. Always provide constructor an initialize variable to avoid programming error, because some of the variable may not be properly initialized. So this is a good guideline to use constructor to initialize all the variables. Thank you.